Hi everyone, so this is the third video for section 5.2. So in this video, we're just going to kind of do some more tests to see if numbers are prime or composite. And we can use a lot of different things here. We can use the divisibility tests, we can use common sense and concepts from our work with prime numbers, meaning the test for prime factors is going to be the main thing that we use here. Okay. So we can use all of these things, but we need to justify our answer, which essentially just means if you put the words prime or composite instead of showing your work, you won't get credit. Just like on the first exam, it said that a correct answer with no work is worth 1 point out of the up to 10 points that a question can be worth. So yeah, definitely show your work. I think that as future educators, I think you're more likely to see eye to eye with me on this, that it doesn't matter if you can get lucky and get the right answer, even if it's not luck. It doesn't matter as much if you can be correct as if you know how you got to that correct answer. Okay, so we're going to look at 223. So we only need to check based on our test for prime factors, specific prime numbers. Okay, so we want to know what is the square root of 223. So this may be a little bit difficult to see at first, to just be like, well, I have no clue. I don't know what's around it. I only know my squares up to 12, and 12 squared is 144, which is a lot lower, and that's fine. But we can use kind of that common sense to try and figure this out. So if we know that 223 is bigger than the square of 12, 144. So we know that we'll need to check 2, 3, 5, 7, and 11, right? Because even 11 squared is 121, which is less. So we're just going to keep listing prime numbers until we get to one that squares bigger. Okay, so we know that 12 isn't prime, but this is bigger than the square of 12. So what about 13? Well, we know that 13 squared, if you don't know this, you can write it out. But 13 squared is 169, which is smaller, than 223. So that means that the square root of 223 is bigger than 13. Okay, and the next prime number that we have is 17. So then let's look at 17 squared, right? Because we're only looking at odds, and 15 is composite. So then 17 squared. So again, if you don't know this, you can just write it out. So 17 times 17 is 289. And so 17 does not belong on this list because the square root of 223 has to be less than 17 because the square of 17 is bigger than 223. Okay, so these are all the things we need to check. 2, 3, 5, 7, 11, 13. So I'm just going to write out all the things we need to check. And then we'll go in and say if they're true or not. So 2 does not divide 223, since 223 is odd. 3, well, I don't know if 3 divides 223, but whatever it's going to be because 2 plus 2 plus 3, so this is 7. So this does not divide 3, since the sum of the factors is not divisible by 3. 5 does not divide 223, since 223 does not end in a 0 or 5. And then for 7, 11, and 13, we really just need to check and divide it out. Yeah, we just need to divide it out. So 223 divided by 7. 7 goes into 22 3 times. With 1 left over, bring the 3 down. 7 goes into 13 1 time. With 6 left over, so because there's this remainder of 6, 7 does not divide 223. So now we're going to try it with 11. So 11 goes into 22 twice. With 0 left over, so this is 0, and then we have this remainder of 3. So because we have a remainder, 11 does not divide 223. And lastly, when we divide by 13, 13 goes into 22 once. With 9 left over, 13 goes into 93. Let's think about this, how many times? Let's list 13. So 13, 26, 39, 52, 65, 78, 91. 13 times 7 is 91. So this one has a remainder of 2. So again, it does not divide evenly. So none of these numbers divide 223. So 223, right up here where I have space. So 223 is prime by the test for prime factors. And this is my answer. Okay, so we'll do one more example of this using 481. Okay, so again, I don't know the squares all the way up there, but I do know that 20 squared is 400, and this is bigger than 400. So that tells me that I'm going to at least check all of the primes up to 20, and it should be pretty simple to see that. It should be pretty simple to see that 20 squared is 400. And you can kind of have in mind these like easier squares that are easier to see, right? We all should know up to 12, and then you may not know anything until 20, and that's fine as long as you can kind of reason these problems out. So we need to check all the primes up to 20. So that's 2, 3, 5, 7, 11, 13, 17, and 19. And so remember that the next prime number after 19 is going to be 23. So we're going to check 23. So 23 squared is, let me just write it out. Because yeah, maybe kind of difficult to see. So 23 times 23, this is 69 and 46. So this is 529. So the square root of 20. So the square of 23 is 529, which is bigger than 481. And remember that we only need to test primes that are less than the square root, so this is bigger. 23 doesn't go on this list. So we just need to check all these others. So 2 divides 481. So I'm just going to do these as we go along. So 2 does not divide 481. Since 481 is odd. 3 does not divide 481. Since 4 plus 8 plus 1 is 13. Is not divisible by 3. 5 does not divide 481. Since 481 does not end in a 0 or a 5. Okay, what about 7? So we don't know just by looking at it. So let's divide 41 divided by 7. 7 goes into 48 6 times. With 6 left over, 7 goes into 61 8 times. With 5 left over, so because there's a remainder, 7 does not divide 481. The next one is 11. So do we have that 11 goes into 41? So 11 goes into 48 4 times. With 4 left over, 11 goes into 41 3 times. With 8 left over. So no, 11 does not divide 481. Oh no, sorry about that. I don't know why I did that. I just wanted to rewrite this. So 11 divides 481, does not. The last one we need to check is 13. Not the last one, sorry. The next one we need to check. This is 13 divide 481. So again, we divide by 13. 13 goes into 48. Wow, glad we listed these things up here. Were nice. So I remember we listed these multiples of 13 just because they may not be something off the top of your head. So 13 goes into 48 3 times. With 91, with 9 left over, then we bring down the 1, and hey, look at that. This is 13 times 7. So this doesn't have a remainder. So 481 divided by 13 is exactly 37. So 13 does indeed divide 481. So that means that 13 is a factor of 481. So since 13 divides 481, 13 is a factor of 481, and that means that 481 is not. Okay, so this one resulted in actually finding a composite number of 481. Okay, so that's the last example we're going to do of trying to determine if a number is prime or composite. But I hope that through these examples, you'll be able to do everything that's on the homework.